Okay, now in this lecture I will discuss the soil modulus and deformation section under the loading. So again I will go to the properties and I will discuss this. So if you are working on your flexible pavement or the rigid pavement, the soil modulus and deformation involve loading impacts, right, under the integrated material models, boundary conditions, and analysis procedures. So I mentioned those as well, so that you can capture the soil stress dependent and nonlinear behavior. So soil modulus represents stiffness is modeled using ABAQUS built-in material models, that is elasticity here. And if you are working on more critical state models like modified claim plasticity model, so you can capture the elastoplastic response as well, right? And for deformation analysis or stress analysis, so pore pressure is important, for which you need to define an accurate mesh model with coupled displacement and pore pressure degree of freedom, so that you can simulate consolidation as well. And also geostatic stiff. If you are using a geostatic stiff in your model, it will initialize equilibrium by balancing the NC2 stress and gravity, ensuring an accurate baseline condition before applying an external load, while the soil procedure model actually model time dependent consolidation, so where permeability and compressibility govern the deformation rate. So this is a very important point you should consider. Right, and then we have pavement soil interaction and stress distribution, right? For which I need to go to the other model, and in this model, let's suppose if I'm using assembly module, or let's say I'm using load module, and now I think it's visible here. So if your focus is, let's say if I'm discussing this multi-layered system here, if your focus is on the soil and pavement interaction, you should consider this layer. For example, we have this layer and this layer, the top one, and the middle one and the bottom one. So these are important in interaction, and let me discuss this in detail. So analyzing pavement soil interaction and stress distribution requires careful attention to the interaction in between these layers. So the interaction may be in between asphalt concrete and base, it may be in between the base and sub-base, and it may be in between subgrade and sub-base, and there are the various technical terms that are used in the transportation engineering. So for the underlying soil, the contact, when you are considering the contact, it's non-linear, it's highly non-linear. So it consider the material heterogeneity and load transfer mechanism. And if you remember in the previous video, I discussed the modeling of the pavements, in which I did a demonstration of LET theory. So keeping in mind those points, material heterogeneity and load transfer mechanism can be handled in ABAQUS with a careful attention to the pavement soil interaction and the interlayer interaction in between these parts here. So layering is also another aspect that you should consider, and sometimes the researchers try to constrain their model based on their idealization. For example, if they are analyzing a pavement structure which is a layered system and it has 3 layers, asphalt, base and sub-base, and each layer properties affect the stress distribution. So even though if assigning different material properties to each layer and meshing them appropriately works for you, maybe using axisymmetric or 3D elements actually depends on the problem. So for dynamic loads like traffic, dynamic analysis tips will have a different meshing approach or layers, and similarly elastic and static will have a different approach. So for each layering system, the properties will affect your simulation. And before I discussed the pavement soil interaction or interlayer interaction, this is the category of the contact definition. The contact is very important. Surface to surface contact with proper interaction coefficients would simulate the interface behavior. And sometimes ABAQUS allows us for tight contacts if there is no slip or frictional contact as relative moment control. So there's also another aspect. So also if it is not recommended, but using quasio elements or interface elements could model potential delimation or shear transfer if you are studying the sub-modeling. Other than this, I also discussed the material models, which is important. Then the interaction is also important. If you are considering the interaction in your model, you should be careful about what you are doing in your model. So each of your material model that you are modeling here will cause troubles for you if you don't understand the nature of these material, because if your material are soft and the loads are high, the interaction will be causing trouble for you. And that's the reason, because the shear transfer and the normal forces are transferring in between layers and the deformation is dominant, so the interaction will be affected, and due to that effect all your model convergence will have problems. So after that we have the dynamic analysis of flexible pavements. So the dynamic analysis we already discussed, but I will try to discuss them in the next video, in which I will discuss the loading mechanism, right? So that will include the vibration, moving loads, or impact events, and all those steps, and also earthquake and vibration simulation. So I'm going to cover that in the module 8-9, right? So I think I should rename them. I will rename them here. So in the next video I'm going to start another hand-on project by considering all these points which I discussed here, and maybe in future, if possible, I will try to include further practical projects to this course where possible. I'm not promising, but I'll try my best to include those in this course here. Anyways, the next video is about full pavement analysis. It will be considered as lab 3. I will assume some dimensions and I'll be using some tools, and those tools will be provided for free. If you have a premium feature, those tools will be provided to you with your project files, right? So other than that, which I discussed here, I will try to make sure that I cover each point for you, and I make it more easier, right? So I will also discuss the loads, etc., which I have discussed in the previous videos. So it's going to be a detailed project. If you are working with your flexible pavement project and you are doing analysis on your own, you will be able to do that if you follow this lab 3 here, right? I will try to discuss each and every detail in this course. So maybe I will combine these. That's going to be 7 and 8, and that's going to be 9, 10. Maybe I will create some categories further. So the final content will also be shared for your convenience. So there are a lot I have covered in this course, and almost everything is free. So just in case if you are watching this course and you are interested in this course, then you can contact me on my WhatsApp number, and I'll provide you access. Thank you so much.